Hello again. So we're gonna do some more multivariable modeling. Last time we talked about interactions a bit in R squared. Now this time we're gonna talk about how to do this with multiple predictors. Oops, let me just make this full screen. Okay, so you may or may not recall, we are going to be using our pairs data. We're gonna mutate it, throw in logged price on top of that, as you can see here. All right, so multiple predictors. We're going to predict the log of price as a function of width and height. So as we can see here, the PP fit. Sorry, I swear I'm an adult. I'm just easily entertained. So we're going to pipe in our whole code. You can see here we start with a linear regression, and we pipe that into our set engine, and we pipe all of that into our fitted model. Log price as a function of width plus height, and we've told it that our data is data peeping, and then we tidy up that whole thing. So we can see that we have 3 significant predictors. Well, 2 and an intercept. Because this is exploratory, we are not looking at the R squared or the F statistic. I would encourage you to do that if you do anything beyond just descriptive here. So here's our model. So we've got an intercept of 4.77 plus a 0.027 increase in width, as well as a minus 0.013. You can read it. We can easily translate our estimates into parameters. But here's the cool thing that I wanted to show you. We can visualize this relationship. Here, this is Plotly. And it shows us, well, the relation. Plotly, please. So you can open up these slides yourself and pull around and play with it. So this is our data, and we can see pretty well that there is some pretty solid structure here. And we can map on each of these variables. It's a really nice way to crawl through our data because we are modeling the relationship between these 3. Particularly, we're trying to predict log price as a function of width and height. There we go. It's pretty cool. And I've got the code to show you how to do it right here, using the Plotly function, or the Plotly library. Here we have it in 3 dimensions. X is mapping out width, Y is mapping out height, and Z is mapping out log price. We can indicate how we want to mark these, put lines in that are gray, and add in scatter. You can also use other kinds of plots. So it's a more interactive plot. It doesn't have to be 3-dimension. This is just a basic sine curve that I've thrown on some colors, and we can kind of zoom in maybe. We can pan, do some cool stuff. So it's interactive. Show closest data on hover. Okay, but what this does allow us is some more interactive plots. There's some really cool stuff. Yeah. Okay, so here's Plotly code here. This is more straightforward. What I've done is I've just plotted a sequence from -2 to +2 in increments of 0.1 and mapped those on to a sine function to get x. Here, done Plotly. You can let Plotly do most of the work for you, which is really nice. You can tell it what type you want and how you want to map this stuff. And I had to go to the internet to figure out how to do color. Okay, so we've done numeric and numeric. Let's do numeric and categorical because we can combine them. It's nice. We are also not limited to 2 predictors, but for my own sanity, we're going to stick with that. You are welcome and actively encouraged to expand. Let's explore a little bit more of our relationship. So we can explore the relationship between price of paintings and surface area and condition that on whether or not an artist is living. We've kind of cheated and combined, like there seems to be like a systematic relationship between the two. And so surface area gives us that. And we've also included here a grouping variable, and we've coded it as artist living. If artist living equals 0, then we mark them as deceased. Otherwise, we mark them as living. Now, how did that come about in this code? So if else, so the first thing we do is the logical assessment. So that is going to tell us what the conditional decides by. So here, if artist living double equals 0, so that means it is equal to and exactly equal to 0 by column, by throughout our whole vector for each individual. Then if that reality is true, we go with the first option, deceased. Otherwise, so else, we go with living. If you've done anything in Excel, these logical operators are pretty much the same. We've made our new variable, artist living. Let's count it. So we can see in our data that most artists are dead. Well, now they're all dead because this is old data. But we want to know if being a living artist has any kind of penalty or not. Plus, it's a pretty nice straight code, straightforward example. Okay, so now that we've prepped the data, we want to just facet it, see if there's a difference. So typically, we can see here the surface area seems to be less than 1,000 square inches. I've already drawn the line through this to kind of just focus on the bulk of it. I'm not one to throw out data, but for the sake of this exercise and not having to deal with the more extreme cases, we're just going to focus on these. Now, there's really like almost nothing above 5,000 square inches, but for the sake of our sanity, we're going to subset. Here's the code to make the plots in case you're curious. We faceted. All right, so for simplicity, we're going to focus only on paintings with a surface area of less than 5,000. It gives us a little more zoom in. We can see here, we've plotted surface as on the x-axis and log price on the y-axis. There might be something here. We seem to have not a lot of cheap things in the bigger surface areas, but there's a lot compacted at the bottom. And I'm not seeing a direct relationship immediately versus deceased and living, but this is why we plot these things. Right, so here's the code. Ta-da! Feel free to pause. You have access to these slides. There's a lot going on. Okay, so orange and purple, probably not the best to like have alphas less than 1 because it creates as a color. However, it did facilitate this illustration because it looks so icky that we couldn't not separate them. So we can see here that it looks better. Faceting tends to help so that you don't have to like force like your eyeball to make those adjustments for you. Also see that living artists are much more close. You know what? I'm not going to tell you what I see. I'm going to let you see for yourself. Because that is what this class is about. I'm just giving you the tools and presenting them in a way that is at least moderately not painful. Okay, code. Again, so you can make the same awesome plots. All right, so we have 2 ways to model this stuff. So we can assume that the relationships between surface and log price don't differ by whether or not the artist is alive. We can also assume that the relationship, if we're only looking at interaction effects, varies by whether or not an artist is living, that they're fully conditional. All right, so effectively, if you think that there are like non-parallel relationships, you need to include interactions. That's why this is the whole module on nonlinear effects. So this model implies that the regression coefficient for an explanatory variable will change as another explanatory variable changes. So this can be accomplished by adding in that interaction variable, which is effectively the product of the two. Multiply them. So here, I've plotted main effects. And both technically interaction effects include both main and the interaction. So the main effect assumes the relationship between surface area and log price. And this is how the model looks. Now, if we assume that there is an interaction, possibly, essentially that the relationships between the two depend, we include that interaction effect. So we can see we have different lines here. Okay, so let's show you how to fit those models. Because I showed you what they look like, let me show you how to do them. Okay, so we are going to just do the main effects first, where log price is the function of predictor 1 plus predictor 2. Then we assign our data, and then we tidy it all up. And then it will spit out kind of most of the important things, not all of the important things, but it's a good first glance. If you hadn't already figured out, I have very strong opinions about what they aren't and are not including in tidy models. However, I made the commitment to teach you all the tidyverse. And this is a logical consequence of that commitment. I have strong opinions. Okay. Here's the plot. Or here is that equation translated. Surface area coefficient, not super helpful. But anyway, let's figure out what's happening. So we're gonna plug in all our data, plug in 0 for dead artists, just so we can get a sense of what is happening. So here we can see that the average is like the coefficient is 4.88 plus this coefficient times surface area. Pop it in. Cool. This is what happens when the artist is dead. When the artist is not dead, be undead even, we can see that we need to add in that extra coefficient. I mean, it's added in both, but it's zeroed out. Right here, this 13 and a smidge. And effectively what that does is it adjusts the intercept. And here, the main effects, as we can see, the slopes are the same. The means are different. So it just shifts the plots, but it doesn't adjust the tilt. So here's it visualized. Way more effective. Okay. So same slope, both the lines, parallel. The rate of change doesn't differ as a function of whether the artist is alive or dead, but the means do. So the intercepts can change. They don't have to, but that is actually what we're testing when we include that grouping variable. We're asking if there's a meaningful difference between these two groups. So it looks like very ever so slightly artists alive are consistently more expensive than dead, which is a little surprising to me. But then again, this is not modern art. This is the French Revolution at times. So let's interpret these things. So all else held constant, for each additional square inch of painting in a surface area, the price of the painting is predicted on average to be higher by a factor of 1. All else being held constant, paintings by living artists are expected to be held higher by a factor of 1.5. 1.15, I cannot read, compared to paintings by artists who are not alive. And paintings that are by an artist who are not alive and that have a surface area of 0 are predicted on average to be worth 132 money units. So you can see where all the pieces are here. I know that this is not news to many of you, but I wanted to include it. Plus, it was already in the syllabus, so I wasn't going to change that. Okay, interactions. So the main way we specify our main effects is only by adding that dummy variable. So models implicitly assume that the paintings are the same slope and are only allowed to have different intercepts. What seems more appropriate in this case? Same slope, same intercept for both colors. Same slope, different intercepts for both colors, or different slopes, different intercepts for both colors. I'll leave this as an exercise to you. All right, here's the plot with the interaction. All we've done is multiplied surface by artist and added that as an extra variable. And it gives us this plot where we can see that there's an interaction because the lines are not parallel. Instead, they kind of look like a hinge. For those of you who, I guess, aren't going to see the real life version, effectively, this kind of interaction I will jokingly refer to as not a psych science, while this one is a psych science. It doesn't have to cross over, but if you want it in a sexy journal, the crossover is like apparently the big thing. If you're an experimentalist, and again, I do not run experiments, so please, your mileage will vary. So here's the fit. What I've done, so you can do this a couple ways. One, if you want all of the elements, you can just have it, instead of plus, multiply. And it will give you both the main effect and the interaction. Another way to do this, if you want to specify out all the pieces, which I tend to recommend as good practice, although that is not tidy practice, is you include surface plus artist living plus surface : artist living. So you spell it out. That way you know what you're going to get. We can see here this parameter, that's what they've done. And tidyverse will automatically do this. However, I find it better to include all the pieces so that you're doing it intentionally. Okay. Here's a linear model with the interaction effects. Ta-da! Right. How do we interpret them? Well, the rate of change in price as the surface area of the painting increases does vary between paintings by the living and the dead. So slopes are significantly different. Cool. Some paintings by living artists are more expensive than paintings by the dead. And some are not. Like, look at the intercepts. So main effects are all the non-multiples. I would recommend just plugging out and calculating them separately to help your intuition, as I've illustrated here. Now, finally, again, I personally prefer to look at the F statistic at the beginning, which is effectively what the R squared gives us. We can see that the adjusted R squared without the interaction explains about 1%, 1.2% of variance. Versus with the interaction, we have an increase of almost 1.7. Yes, there seems to be added benefit above and beyond just chance alone. So third order interactions. Can you do that? Sure. Could you do fourth, fifth, sixth, etc.? Yeah, technically you can. However, should you? I would say no. Because the interactions are all within the context of your data and the centering gets weird, the coefficients get weird. You can do it, but I recommend doing it with theory or being very prepared for having weirdness. I've embedded a YouTube video if you would like. Effectively, just because you can model a three-way interaction doesn't mean you need to. Because, yeah, Just because you can doesn't mean you should. So that's wrapping up. We have some extra sources today, including us Steven Spielberg. So yeah, I'll see y'all later. Bye.